Hello and welcome to another math video. Today we will be taking a look at how to use the point-slope form of an equation for a line. So first of all, what that looks like. So we have point-slope form here. So this is the equation of a line through the point x sub 1, y sub 1 that has a slope of m. So we take our variable y, subtract whatever the y coordinate is, our y sub 1, and set that equal to the slope m multiplied by that quantity x minus x sub 1. We don't use this formula as much. It actually comes straight from our slope formula and looks like that. We just replace the x sub 2 and y sub 2 with the actual variables x and y, and then we multiply both sides of the equation by that denominator. That's how we end up with our point-slope form. So that's where it comes from. Now if we're going to write an equation for a line using point-slope form, as long as we have this information, we can go straight to the equation. So in this case that would be y equals, or sorry, not y equals, y minus the 2, because that's our y coordinate, equals the slope 3/5 times x minus the negative 5, so I'll jump right to plus 5. So again, that's just taking those values, plugging them into that point-slope form. Again, there's a question here at the bottom. You can give that one a shot. If you want to pause it while you do that, then I'll go ahead and work through it next. So this one you should have gotten y plus 1 equals negative 3 times x minus 7. Again, notice there with the negative 1, y minus a negative 1 would be the same as y plus 1. Alright, now here it's a little bit different information. Instead of the point and the slope, we are told 2 points. So we need to find the slope, and then we can use one of those 2 points in order to write the equation. Let's see, so if we find that slope, again, you could use the slope formula. Again, oftentimes what I just do is do a little sketch of the graph. So 3, 2 would be around here. 5, 8 would be to the right and above that. See, and again, I always start at the left and I want to find my rise first. So from 2 up to 8, that's a rise of 6. And from 3 over to 5, that's a run of just 2. So of course that's not drawn to scale, but looks like the slope is 6 over 2, which of course reduces down to 3. Once I have that slope of 3, I could use either point in order to write the equation for that line. I'll go ahead and do both, one at a time of course. So using 3, 2, I get y minus 2 equals the slope of 3 times x minus 3. Using the 5, 8, I get y minus 8 equals the slope of 3 times x minus 5. So again, a little bit different there with that one. Again, you could try the same thing with the negative 5, 0 and the 0, 7. If you want to go ahead and give that one a shot and pause, then I will do that when you restart. So again, same sort of thing. If I were to calculate the slope of this, I might just throw out a little sketch there. So negative 5, 0 be somewhere around here. 0, 7 somewhere up here. So I would have to go up 7 and then right 5 in order to go from one point to the next. So that slope would be 7/5. And again, I always like to start at the left point and do the rise and then the run. So using the negative 5, 0, I would have the point y minus 0 equals 7/5 and then x plus 5. So with that one, I'm just kind of emphasizing the 0 there by including it. Of course, we could get rid of it. It would just be y. If we use the other point, the 0, 7, then we have y minus 7 equals 7/5 times x minus 0. So again, you could change that a little bit as well. So again, those cover the 2 possibilities for the equation in point-slope form. Next we're going to talk standard form of a linear equation. So we have that here, a times x plus b times y equals c. A, B, and C just have to be real numbers, and A and B can't both be 0, but one or the other could be. So writing this equation in standard form, first thing we want to do is get rid of that fraction. And when we do say standard form, we are wanting to have integer coefficients. So if you multiply both sides of the equation by 4, then that will get rid of that fraction for you. We end up with 3x minus 20. And then we just want to get the x on the same side as the y. So I would subtract the 3x. And just because this is kind of standard how it's written to put the x first and then the y, I will do that as well. And there is the standard form of the equation for that line. You can go ahead and try that with the y equals 9.1x plus 3.6 to put that into standard form. And if you want to pause, I'll go ahead and do that. So one thing we can do with this is, to get rid of the 9.1 and 3.6 is multiply by 10. So if I do that, I get 10y equals 91x plus 36. Subtract the 91x from both sides, I get negative 91x plus 10y equals 36. So hopefully you came up with the same thing. So writing equations for lines, we have a few different tools we can use. We got the slope-intercept form. That works well if you know the slope and the y-intercept. Point-slope form. It works well if you know the slope and a point, or if you know 2 points. And then the standard form, they don't mention it here, like when this is useful. Standard form tends to come up a lot in real-world problems where you're selling 2 different types of things or 2 different types of rates. Standard form kind of just naturally it gets used a lot for word problems, and so that's one of the nice things that we have for that, even though we don't have a lot of the obvious things like the slope or intercept looking right at us kind of a thing. So graphing an equation using intercepts, I'm just going to do some sketches here. Of course it's nice if you have a grid, but I also want to show again how to do a half decent job at least of drawing a graph. First of all, for this equation, again, it is in standard form. If I find the intercepts, it works out pretty well. So in order to do that, I just make a little table of values. And I want to find if x is 0, what is y, and if y is 0, what is x. So if I plug a 0 in for x, then that x is 3 times 0 would be gone, and we would just have 5y equals 15. And this works out well because then you divide by 5, you find out that y is 3. Likewise, if y is 0, then the 5 times 0 is gone. We just have 3x equals 15. Divide by the 3, we get x equals 5. Now, one thing I don't necessarily like about this example is that it's a 3x and the y coordinate ends up being 3. It's a 5y and the x coordinate ends up being 5. So I don't necessarily like that because people start to think that that happens all the time. It just so happens in this case because, and it'll happen every other time, where we have 3 times 5 equals 15. So it doesn't happen every single time, so try to just not think that that'll happen every time. That does give us 2 points, so 0, 3, and 5, 0, so I need to make sure that when I do my sketch for my graph that I include those points. So 0, 3, and then 5, 0. So I can put those points on there. So 0, 3, 5, 0. So again, when you do a graph, you need your axes. Now I should have arrows here, and I should label my x-axis and my y-axis. I should include a scale over here and down here, even though I'm not really using it. So you should label your axes. You should always include marks to show what your where your marks are. If there's nothing marked here, then it's assumed you're going by 1. If you want to change the scale to anything else, you need to show what that scale is going to be. Besides that, you just want to fairly accurately plot your points, and then do your best to draw a decently straight line through there. And it's a line, so it does have arrows on both ends, so don't forget that either. Let's you go ahead and try to graph the 2x minus 4y equals 8. I don't think I'll take a look at that one, but again, give that one a shot to see how you can handle it. So parallel lines, hopefully we all remember the slopes for parallel lines are equal, and the slopes for perpendicular lines are negative or opposite reciprocals of each other. Now this excludes vertical lines because of course the slope of a vertical line is undefined, and you can't have a reciprocal to undefined or be equal to undefined. So that's why they make that note that no one line can be vertical. They do mention here too, parallel lines, the y-intercepts have to be different. They cannot be the same. If the slopes are the same and the y-intercepts were the same, then it would be the same line. So just make sure that that's not the case either. Otherwise, what we're going to take a look at doing here is, given that we want to write a line parallel to y equals 6x minus 2 that goes through 1, negative 3, what would that be? And they are asking for slope-intercept form. Since we're parallel to y equals 6x minus 2, that means that the slope of our line has to be the same as that one, and the slope for y equals 6x minus 2 is 6. So now it's really just a different way of giving us the information that it has a slope of 6 and goes through the point 1, negative 3. Now they want slope-intercept form, but it's much easier to start with point-slope form with this information. Point-slope form would be y plus 3 equals 6 times x minus 1. In order to get to slope-intercept form, we just have to distribute the 6 and then subtract the 3. So distributing the 6 gives us y plus 3 equals 6x minus 6. And then subtracting the 3, we get y equals 6x minus 9, like that. Next example, we've got y minus 4x plus 2/3 is the equation we're given. It's going through the point 8,5. However, this time we want a line perpendicular to this, so it means our slopes aren't the same. It means our slopes are the opposite reciprocals. So to emphasize that, I usually do my little perpendicular sign. So the slope perpendicular to negative 4 would be a positive 1/4. Again, notice the 2/3 doesn't really come into play, neither does the minus 2 here. But again, going to be a little easier to go to point slope form. So if I do that, we would have y minus 5 equals 1/4, and then x minus 8. Thankfully for us, the 1/4 of 8 will work out nicely. So if we distribute that, we get y minus 5 equals 1/4 x minus 2. Add the 5 to both sides in order to solve for y and get that into slope-intercept form. So y equals 1/4 x plus 3. See, again, there are a couple problems there at the bottom for you to try. So if you want to go ahead and pause, then I will go and do those in just a second. Alright, so for this first one, they want us to be parallel to 4x plus 2y equals 7 and go through the point 4, negative 2. So they don't exactly give us something we can straight up grab the slope from, although once you do get used to these standard forms, you realize that, yeah, there is actually a way to do that, but we'll see if you can't figure that out on your own. So a different way we could do that would be to solve that for y ourselves and then get the slope from there. So dividing by 2, we get negative 4 halves x plus 7 halves. Now the 7 halves does not really make a difference for what we're doing with this equation, because we just want to get the slope from here. So the slope we have is negative 2. We're parallel, so our slope that we're using would be negative 2. And we're going through the point 4, negative 2. Again, point slope form will be the easiest thing to do here. So y plus 2 equals the slope of negative 2 times x minus 4. Distributing the negative 2 gives us y plus 2 equals negative 2x plus 8. And then we subtract the 2 to get it into slope-intercept form. We get y equals negative 2x plus 6. So there's the slope-intercept form there. And again, if you want to do a little thinking about the standard form and how you could get the slope from there. Again, we had the standard form 4x plus 2y equals 7. That has a slope of -2. So you can think about how to go from one to the other. There is actually a pattern there. If you see it, that's great. If not, it's not too tough to write that in two slope-intercept form each time. The next example, going perpendicular to y equals 2/3 x minus 1 through the point 0, 6. They actually give us this y-intercept here. So if you didn't notice that, you could actually just do what we've been doing. We do want to be perpendicular to the 2/3 x minus 1, so that means that our slope would be the opposite reciprocal for 2/3. So the slope would be -3/2, and like I said, they gave us really the y-intercept of 6. So then that equation just becomes -3/2 x plus 6. And there we go. Well, hopefully you found this helpful, and thank you for watching.